Hello friends. In this video we'll be watching about the differences between a solution, suspension and colloid. A solution is a homogeneous mixture of two or more substances. Example salt solution, sugar solution, seawater. Seawater is a solution because it contains many dissolved salts in it. Suspension is a heterogeneous mixture of two or more substances. Examples include soil, mixture of chalk and water, seawater. Seawater is also a suspension because it contains many solid particles such as rocks and corals. Colloidal solution is a heterogeneous mixture of two or more substances, but it appears to be a homogeneous mixture. This is actually really interesting. Examples of colloidal solution include milk, mist, cloud, foam, cream, etc. There are many examples of colloidal solution. So now let us start actually distinguishing between a solution, suspension, and a colloidal solution. Colloidal solution is also known as colloidal salts. It's also known as a colloid. It has many names. Let us first see under what categories we are going to separate these mixtures. We are going to separate a solution, suspension, and a colloid on the basis of their size of particles, their stability, and their Tyndall effect, whether they show Tyndall effect or not. Tyndall effect is the scattering of beam of light by particles in a solution or in a suspension or in a colloid. Let us see which mixture possess Tyndall effect. Now let's start with solution. A solution the size of particles in a solution are very small to be seen with our naked eyes. It can easily pass through a filter paper, so the solute, which is the dispersed phase, cannot be separated by the solvent, which is the dispersing medium, by filtration because the particles can pass through filter paper, so they can't be separated by filtration. The size of particle in a solution is less than 1 nanometer in diameter. 1 nanometer is nothing but 10 to the power minus 9 meter. It's really, really small. On the basis of the stability, a solution is stable. Stable means that the particles do not settle down when left undisturbed. The particles in a solution do not settle down because they are dissolved in this solvent. Next, on the basis of the Tyndall effect, the particles of solution are very small to possess Tyndall effect. They do not scatter a beam of light passing through the solution. Hence, the part of beam of light is not visible in the solution. When the particles are so small, they can't block or they can't scatter a beam of light. So, a solution does not possess Tyndall effect. So now we have differentiated solution from colloidal solution and suspension by on the basis of size of particles, stability, and Tyndall effect. Size of particles of solution are very small. The particles of solution are stable, and solution does not possess Tyndall effect. Now let's go to suspension. In a suspension, the size of particles are very big, in which we can see with our own naked eyes. They easily they do not pass through a filter paper. Hence, the suspended particles can be separated from its medium by filtration. Easily, they can be separated by filtration. By filtration. Now, going to the stability, the particles in a suspension are unstable. So when we leave the particles of suspension undisturbed for a while, for example, if we leave a solution of soil, a mixture of soil and water, when we leave it undisturbed for a while, the soil particles will be down, will be below the water, will have sunk. The particles of suspension are therefore unstable, they settle down when left undisturbed. Now, many people tend to get confused between stable and unstable. Stable means the particles do not settle down when left undisturbed. Unstable means the particles settle down when left undisturbed. Remember, it's opposite. Stable means they do not, unstable means they do. Remember like this, it's a really easy way to remember. Particles in a suspension scatter the beam of light and hence they show Tyndall effect. But when the particles settle down when left undisturbed, as they are unstable, the particles settle down when left undisturbed. The particles of suspension no longer scatter a beam of light because now the particles are very big in a suspension. When the big particles block the part of beam of light, they possess Tyndall effect because the light becomes visible. But when the particles are itself too small to block the particles of light, they do not show Tyndall effect. So when, for example, when we take soil and water solution, soil and water mixture, the soil particles are very big to block the beam of light, so they possess Tyndall effect. But when the soil particles goes down, only the water particles stays up. Water particles are very small, so they do not possess Tyndall effect. Now let's go to colloidal solution. The size of particles in a colloid are too small to be seen with our eyes, and they can also not be separated by filtration. They can be separated by a special process called centrifugation. We can watch that in our later videos. But the particles are large enough to scatter a beam of light. They are small to be seen with our naked eyes. They are small to be separated by filtration, but they are large enough to scatter a beam of light. On the basis of their stability, colloids are stable, they do not settle down when left undisturbed, and colloids scatter a beam of light and they show Tyndall effect. So we have now seen suspension and colloids. Suspension are the particles are very big, they are unstable, and they show Tyndall effect only for a short time, for a small amount of time. After they settle down, they no longer show Tyndall effect. In a colloidal solution, the particles are small to be seen with our naked eyes, but they are large enough to scatter a beam of light. They are stable, they scatter a beam of light, and thank you so much for watching this video. We will provide a lot of beneficial videos for your exams or for general knowledge like this in the future. Thank you.